In here, what is happening is the zinc is losing electrons. You can see in here what we have. We have an electrolyte, that is Z1SO4, and we have another electrolyte, that is copper sulfate. Then we have a zinc electrode and a copper electrode. We have a zinc electrode and we have a copper electrode. Okay. We have a zinc electrode and we have a copper electrode. So what happens generally in any battery? Redox reaction takes place. So what is redox reaction? That is reduction as well as oxidation. So redox means both reduction as well as oxidation reaction takes place in the battery. So first you can say reduction, sorry, oxidation occur. What is oxidation? Oxidation is removal of electrons. So here zinc oxidizes, that means the zinc metal becomes zinc ion and it is received, okay, in the electrolyte Zn2+. And when the zinc loses 2 electrons, this, you can say, electrode, this side electrode becomes rich in electrons. Hence this side electrode becomes negative. So the electrode on which oxidation occur, the charge on that electrode is always negative. Hence we call it as anode. Now on the other side, in here you can see in the copper sulfate, when we add some water in the copper sulfate, the copper ionizes. It ionizes to Cu2+ and SO4 2-. Though the whole, you can say, charge on this electrolyte is neutral, but still the copper and the sulfur, they are a bit ionized. So when the copper is ionized and on one side there is enough electrons available, so what the copper will do? It will absorb or it will accept the electron from this copper electrode and gets deposited on the copper electrode. Okay, so this reaction occurs. Cu2+ gains 2 electron, becomes copper metal. On the one side, on the first half cell, zinc loses 2 electron, becomes zinc ion, copper accepts 2 electron and becomes copper metal. So this zinc electrode loses mass with time. Okay, because the zinc is being transferred to the electrolyte. When the zinc is becoming a ion, the zinc metal is becoming a ion by losing 2 electrons. While copper, on the other hand, is accepting 2 electrons and it is getting deposited on this electrode. So after some time, this copper will be deposited on this electrode. Okay. After some time, the copper will be deposited on this electrode. Okay. Clear? So now you can see in here, on one side there is generation of electron and on the other side there is consumption of electron. Hence the battery continuously provides electricity. On one side, because of oxidation, there is generation of electron. On the other side, because of reduction, there is consumption of electron. Hence the battery is a continuous process. But after this, some time, this reaction will stop. Why? Because you can say in here, as the zinc ion, you can say as this electrode or you can say electrolyte becomes rich in zinc ion. Okay. As this electrolyte becomes rich in zinc ion, so the electrolyte will become positively charged. When the electrolyte is becoming positively charged, and on the other side, we will get rich in sulfate ions. Okay. We will get sulfate ions. SO4 2-, SO4 2-. Okay, it will be rich in sulfate ions. So the zinc ions will, or you can say the zinc electrolyte, Zn-SO4 electrolyte will become positively charged and it will not allow any more electron to flow to the other side. It will not allow any more electron to flow to the other side. Okay, and since you can say sulfate ions, SO2 ions, when they accumulate, the copper sulfate electrolyte will also become negatively charged. Hence, the copper will no longer accept any electron. So now we reach equilibrium condition. But that is not required. Why will we can say if we reach equilibrium condition, then just the battery will work for some 5, 10 to or 15 seconds and it will stop working. The battery will work for some 10 to 15 seconds until the accumulation of charge occur, then after it will stop. But we don't want that. Hence, what we use a salt breeze. So through this salt breeze, what will happen is the excessive zinc ions will start moving towards the sulfate ions. Okay. And excessive sulfate ions will start moving towards the zinc ion. Okay. The zinc ion will start moving towards the sulfate ion, and the sulfate ion will start moving towards the zinc ion. Okay. The zinc ion will start moving towards the sulfate ion, and the sulfate ion will start moving towards the zinc ion. Hence, this will again start the battery. Why? Because now, since the zinc and sulfate ions are being transferred from one side to other side, again, the net charge on this electrolyte will become 0. Again, the electricity flow will start. The zinc will start losing electron, or it will generate electron, and the copper will start accepting electron and it will get deposited on the copper. So this is how your battery works. In your battery, we have a cathode, okay, that is the positive side, and we have an anode, that is the negative side. Okay, we have a cathode that has the positive side, and we have an anode that is the negative side and the electrolyte. Okay, so this is the working of a battery. The battery is used to store charge for a longer period of time. If we want our vehicle to run for 4 hours, 5 hours at a speed of 60 or 70 km per hour, then we need this. You can say we need battery. Okay. Then comes static energy storage systems or electrolytic capacitors. So the capacitors are used to store energy generated from regeneration. Okay. The capacitors are used to store energy generated from the regeneration. Remember, your batteries take 4 to 5 hours to fully recharge. Your capacitor takes only 10 to 15 seconds to fully recharge itself. Okay. Your batteries need 4 to 5 hours to recharge itself. And your capacitors requires 10 to 15 seconds to recharge themselves. So batteries have high energy density, but low power density. That means batteries can store a lot of energy, but they cannot deliver a lot of energy instantly. While capacitors, they have low energy density and high power density. That means the capacitors can say they cannot store a lot of energy, but they can accept or reject a lot of energy. Okay, lot of energy per unit time. The capacitors may not store a lot of energy, but they can accept and reject a lot of energy per unit time. This is the reason why your batteries have high energy density and low power density, while your capacitors have low power density and low energy density and high power density. Because your regeneration, when you will be braking a vehicle, you will brake your vehicle in just 5 to 10 seconds. So your system should be capable of storing energy within 5 to 10 seconds, because regeneration will occur just for 5 to 10 seconds. When you will be braking the vehicle, it will just be a small event, 5 to 10 seconds event. But in that small event, you can say discarding a lot of kinetic energy of the vehicle. So your system should be developed in such a way that it can accept that much amount of energy very fast. Hence, batteries are not used for, you can say batteries are not used for regeneration, not used for energy storing the energy. generated during regeneration, while capacitors are used. Now, why capacitors are used? So before going to that, let us know the working of a capacitor. So in a capacitor, we have two plates. Okay. In capacitor, what we store? We store static energy. In a battery, we store chemical energy. Remember, in a battery, we store chemical energy, but in a capacitor, we store static energy. Okay. In a battery, we store chemical energy, while in a capacitor, we store static energy. So how the static energy is stored? Let's say we have a capacitor with two plates. When this capacitor is connected to a power source, let's say this capacitor is connected to a power source. So when this capacitor is connected to a power source, on this plate, charge develops. On one side, we have negative charge. On one side, we have negative charge. Okay. On one side, we have negative charge, while on the other side, we have positive charge. Okay. So now when we just remove this battery, now this charge has no path to flow. In capacitor, there are two plates, plate A and plate B. So when we remove the power source, now this charge have no path to flow back. Hence, the charge is stored as static energy. Now, if we connect any load, across these terminals, so this bulb will glow for some time before complete discharge. So this is the working of a normal capacitor. Now, capacitor has two formulas. I am leaving something in the capacitor. It might be thinking, sir, there is something missing in the capacitor. Yes. So for that, let's see. So your capacitance depends on the total charge and the voltage across the plates. Also, your capacitance depends on the, you can say, permittivity of the material and area along with the distance between the plates. So the area of the plates, okay, the area of the plates and the distance between the plates, D. The area of the plates and the distance between the plates. Okay. Getting it or not? The capacitance of a capacitor depends on the area of the plate and distance between them. Along with the capacitance is also dependent on the charge on the plates and the potential difference across the plate. So engineers, for a lot of time, they try to improve the capacitance of a capacitor. So they have used different techniques. So using this second equation, so what the engineers try to do is they try to increase the area of the plates. But as we start increasing the area of the plate, we will reach a certain threshold. Why? Because we will not be able to create small and efficient capacitor. We always have to create very big capacitor if we are always increasing the area. So they have reached the area threshold. We cannot, let's say if the capacitor is small, then the area is also limited. Okay, we can't have more area if the capacitor is small. Again, if the capacitor is small, then the distance between the plates is also restricted. We can't have much smaller distance between the plates if the capacitor is small. Your mobile phone has capacitors, and those are very small capacitors. So if the capacitance has to increase, so we need to increase the area. But when we are increasing the area, we are not able to create a small capacitor. And if the capacitance has to increase, we have to reduce the distance. But if the capacitor is small, we are not able to reduce the distance. So can we increase the charge? Charge is completely dependent on the, you can say, power source. Okay. So in our mobile phone, you have a small power source. Okay. So what they have done is they have to decrease the potential difference. So in order to decrease the potential difference, what the engineers did is they did a phenomenal job. So they included a dielectric medium in between these capacitors. Okay, that has a high permittivity, and because of this dielectric, what happens is the dielectric has polarized. So it becomes positive on one side and negative on the other side, thereby reducing the net potential difference across the plate. Okay, dielectric medium. thereby reducing the potential difference across the plate. So this is the reason why our capacitors have dielectric medium. The dielectric medium helps to increase the permittivity, and because previously there was air, okay, the permittivity of the air is not that good, but they have included a dielectric material whose permittivity is very good. So this increased the capacitance, and also the dielectric material is able to reduce the potential difference across the terminals. The dielectric material, you can say, helps to reduce the potential difference across the terminals. So now this is the working of a normal capacitor. But in our EVs, we don't use normal capacitors. For electronics, yes, we use normal capacitors. But for regeneration, we use supercapacitors. We use supercapacitors. So what is the difference between a normal capacitor and a supercapacitor? The difference is you can say in normal capacitors, okay, there is no plate coating, but in supercapacitors, the plates are coated with graphene material. In supercapacitors, the plates are coated with graphene material. Okay. Now, pH, okay, graphene material. Okay, so graphene is a porous material. Okay, graphene is a porous material, just like your pumic stone. You have seen the pumic stone. Your pumic stone is a porous stone. So your graphene is also a porous material. Okay. Okay. Your graphene is also a porous material. So now when the porosity of the material is increasing, obviously the total exposed surface area will also increase. When the porosity of the material is increasing, the total exposed surface area will increase. This is just like a stone. Let's say the stone is smooth and we have another stone that has small holes in it. So one stone is smooth and another stone has small holes in it. So obviously the stone which is smooth has less exposed surface area as compared to the stone that has holes in it. So by taking this phenomena into account, what the engineer has started, the engineers, they have started to deposit to coat the plates with graphene, thereby increasing the total exposed surface area. So when they are increasing the surface area, the capacitance has increased 1,000 folds. So this is the difference between, 1,000 times, not volts, 1,000 times. So this is the difference between a normal capacitor and a supercapacitor. In a normal capacitor, there is no graphene coating on the plates, but in a supercapacitor, there is graphene coating on the plates. Because of that graphene coating, the capacitance of the capacitor has increased by 1,000 folds. The capacitance of the capacitor has increased by 1,000 folds. Okay, clear? So this is the working of your capacitors and battery. Then after, we have some other types of capacitors, like a pseudo capacitor. A pseudo capacitor is just like a battery, but it is small. Okay. But pseudocapacitors are not used for regeneration. They are used in some devices, but they are not mostly preferred for EVs. Then we have double layer capacitor. This double layer capacitor, you can see these are graphene coatings. Okay, these black layers, these are graphene coatings. So graphene coating increases the total surface area on the plates, thereby increasing the capacitance by this formula. That is C is equal to permittivity multiplied by the area of the capacitance divided by the distance between the capacitors. Area of the plates divided by the distance between the plates. Okay, so you can see graphene supercapacitors exhibit the potential to act as a primary power source of an electric vehicle due to their short range time and relatively high power density. Okay, so got it. So this is a small topic on energy storage system. So if you have any doubt, you can ask. So energy storage system, we know about batteries, how the batteries work. Okay, so let us know about the chemistry of your lithium-ion battery. Okay, so this is the lithium-ion battery chemistry. Remember, the lithium-ion battery works on a very good principle known as intercalation. If you have to charge your battery, so what you have to do? When the battery is discharging, then remember, electrons flow in the external circuit. In here, the electrons flow in the external circuit. Okay, the electrons flow in the external circuit, but ions flow in the internal circuit. Okay, you can see the lithium ion is flowing from one side to another side in the internal circuit. So when discharging, the ion will move from anode side to the cathode side inside the battery. And during charging, the same ion will flow from the cathode side to the anode side during charging. Okay. So now the engineers, they were trying to figure out how to develop you can say a chemistry where we can store the ion. The ions won't be going for any bonding. Rather, the ions will be in a covalent bond or in just a small electromagnetic or electromagnetic bond, and it will be very easy to break the bond, and again easy to create the bond. Again during charging, it will be easy to break the bond, and it will be easy to create the bond. Okay, so they have came with a very good technique, that is a lithium ion. So what they have done is, in the anode side, they have combined lithium metal with graphene layer. So there is a graphene layer. Graphene has a hexagon structure. So what they did is they stored the lithium atom inside this graphene structure. So now during discharging, when the lithium ion moves out of this structure, the lithium, what is the, you can say, configuration of lithium? Lithium is, it has 2 electrons on its innermost shell and 1 electron on the outermost shell. So it gives 1 electron, then comes out of this graphene structure, and it is intercalated. Intercalated means, you can see this cobalt, lithium cobalt oxide. So the lithium LiC6, okay, breaks to graphene and lithium ion, generating 1 electron. The lithium will flow inside the electrolyte. It will reach the other end, this end. Okay, and it reacts with the cobalt oxide there, along with the electron that is flowing in the external circuit, becomes lithium cobalt oxide. So lithium cobalt oxide means the lithium is again stored in intercalation. The lithium is stored in intercalation. Again, the lithium is very easy to break from that intercalation, and again it is easy to put inside the graphene. Again, it is very easy to remove from the graphene and again to put it inside the cobalt oxide. So because of this intercalation, your lithium ions have very efficient batteries. Okay, so this is all for today's demo.